This is section 1.2, day 1, and today we're going to be talking about functions. By the end of this, you should be able to identify, evaluate, and determine the domain of a function. And so a function is a relation between x and y and those values. There are some different names that we've used for x and y, some terms that you've seen along your way. When you kind of first learn about functions, you talk about input and then output. So you talk a lot about, like in 4th grade, where you put something into a function and then you get something out. Now that you're in the big leagues, we say that that's the independent variable and then the dependent. So x is completely independent. You are picking the value of x. Y completely depends on whatever you pick for x. So you can't have a y without first having an x. The domain is all the x values and range is all the y values. So talking about some characteristics of a function, this is the example I usually use for students about how to decide if something is a function or not. Deciding if the time of the day, how that relates to the temperature at that time. So we're just going to make up a fictional day here, a really bad day in Minnesota. At 1 o'clock in the afternoon, it is 0 degrees, which could happen, will happen, unfortunately. At 2 o'clock in the afternoon, we fell down to -12, which is kind of a bummer. But by 3 o'clock, believe it or not, we jumped up to a balmy 23, close to shorts weather for Minnesotans. At 4 o'clock, we went to 54 degrees, looking even better now. 5 o'clock, it was still 54. We didn't do any change there in terms of temperature, which is totally legal for me to have 2 different times of the day headed to the exact same temperature. That could happen. And then at 6 o'clock at night, we just scorched it up to 101. What we're talking about here in terms of a function is making sure that every single element in A, the first group in terms of time for our example, is matched to an element of B. So everything in A must be accounted for, must be used. The second part, some elements of B may not be matched with any in A. So that means there might be some leftovers, and there was for us. We didn't even use 73. And there's a lot of other temperatures in here that we could have listed that we didn't end up using. 2 or more elements of A may be matched with the same element in B. And that's what happened here at 4 and 5 o'clock. Both of them, 2 elements, went to 54 degrees, which is totally legal. What's not legal is an element of A cannot be matched with 2 different elements of B. It would not be okay for 6 o'clock at night to be 100 degrees and be 23 degrees. It's one or the other. It can't go to 2. And that's where we start to talk about the definition of a function, is what can it be and what can't it be. So some of the ways that we decide if something is a function, we've got 3 different ways that we do that. Graphically is like visually. If you could see the graph, if you could look at it, how would you decide that it is a function? And graphically is the vertical line test, which we're going to call the VLT. Later on, we're going to use learn about the horizontal line test, and we want to make sure that we're keeping track of both of them. Next up is graphically. So vertical line test, you're just going to be drawing vertical lines. If you hit the function twice, then not a function. Numerically. So numerically means we're going to be looking at the numbers. We're going to be looking at data, an XY chart possibly, or some points. And we're just checking to make sure that every x has exactly, no more, no less, 1 y. That essentially means you're not going to have any repeated x's. Last up is algebraically. This is going to be if you had a formula to look at. So 2x plus 3y equals 4. So you don't have a graph to look at. You don't have any XY chart. You don't have any data. You're just looking at the equation, the algebraic equation. So what you need to do is solve for y. And what you're looking for is any time you end up with a plus or a minus sign. You are on the lookout for a plus minus. And that plus minus only happens when you square root both sides. So if you remember, x squared equals 9, and if you were to solve that, you would root both sides, and you would end up with x equals plus or minus 9. Plus or minus 3. Because positive 3 squared is 9 and negative 3 squared is 9. So that's a case where we got a plus or a minus. If you get a plus or a minus, that means it's not a function. So you're going to solve for y and see what happens. If you end up not getting a plus or minus, you're good to go. It is a function. The first thing we're going to do are going to be visual. This is my fault. I started before I had the graphs on there. Your notes have these graphs on there, and I'm just going to quick sketch them. And all we're doing, since we are visual right now, we visually have graphs to look at. We just need to do the vertical line test. So I'm just drawing vertical lines, and as long as I only hit it once, this is a function. Drawing vertical lines, I hit the function twice all the time. So this is not a function. Using what we were talking about above, that's saying that if I were to plug in a 1, I'm getting 2 different y values. At 1 o'clock, I'm getting 2 different temperatures, and that's not okay. That's not a function. Next up, I'm not hitting it twice, so this is a function. Our next example is going to be talking about numerically. So now I'm looking at data. I actually have some points to look at. And so we are just going to make sure that every x has exactly 1 y, which just means there's no repeated x's. So I'm looking at my x's. I've got a 1, a -5, and a 7. That's no repeats. So yes, this is a function. And then I'm supposed to tell the domain. And the domain is 1, -5, 7. It is just all of the x values. And then the range is all of the y values. So we would have 3 and 4. I don't need to, and I shouldn't, write 3 again because it's just a repeat of a value I already have. Last one is algebraically. So we've got some equations here. And so our job is to solve for y, looking out for plus or minus. So I'm going to fence that. I'm going to subtract 1 and subtract that. So I've got -1 minus 2x squared. I did not end up doing a plus or minus. I did not root both sides in order to solve for y. So we're good. This is a function. Next one, I'm going to still solve for y. So I'd have y squared equals 6 minus x. And here's the problem. When I go to square root that y to get it by itself, I square root over here. And as soon as you do that, you end up with a plus or minus. And as soon as you have that, this is not a function. So today was all about deciding if things are functions. You have 3 big ways to do that. Graphically or visually is the vertical line test. Numerically, when you're looking at data, just make sure that every x has 1 y. And algebraically, solve for y and make sure that you don't get a